So once the double pulse software has been loaded, what I need to do is to check the timing difference between all 4 of my channels on the oscilloscope, and the primary reason why that's being done is because I'm using a current clamp to capture some of the signals. Okay, so this is the current clamp, and this is the differential voltage clamp, and over here you can see the other half of the current clamp actually wrapped around a wire, and then I've got a 50 ohm resistor across the output of the AFG31052, and then this goes to the differential probe, and then just the channels 1 and 2 on the normal oscilloscope probes. Looking at the AFG31052, all I've done is set up the double pulse software to put out a couple of pulses on a 5 volt peak waveform into a 50 ohm load, and then I'll look at the edge of them using the oscilloscope. So repositioned to show the oscilloscope screen, you can see here these are all 4 traces being displayed at the same time, and what I'll do is I'll just turn off channel 3 and 4 temporarily. So now I've just got the 2 channels that are measuring the voltage, and you can see they're pretty much well aligned. If I move these out a little bit, so you can see there that both waveforms are pretty much well matched. Rise time is as well, so the rise time is fairly evenly matched across them, and my differential is floating down in the tens of picoseconds, which is fine for me considering I'm going to be measuring signals sort of like 10 nanoseconds and above. What I'll do is swipe off channel 2 and I want channel 4. So channel 4 is marked from the differential voltage probe, and you can see immediately that I've got a differential between those 2 signals. Changing channel 4, changing channel 4. So the rise time is about double on this, and I've got around about 3.8 nanosecond delay between the 2 waveforms. So to correct that, what I need to do is go to channel 4. Off the other I have a deskew function which I can set to this here, which will do clear it nanoseconds. I enter, and you can see now the waveforms jumped back in. My differential between the 2 is back down in the picoseconds. It's just the rise time is slightly higher, so that's sorted out the differential between those 2 channels. So we'll add in channel 3, swap off channel 4, and the first thing you see, I can't get the slope upwards at this moment in time on channel 3 because it is quite a ways out, and you see it's starting to come in there. Let's go over. So there you see, we'll put our differential in channel 3 and rise time for channel 3. So you can see now I'm up to 175 nanoseconds delay. And rise time's gone a little bit on channel 1 because I've changed the settings, but the rise time is like 100 nanoseconds on channel 3. So for the type of tests I'm doing, this current probe is probably going to struggle. I can we'll go for a deskew, and what we'll just do, I'll set this for the 175. 175 nanoseconds. I need to pay attention just here because this scope has a maximum setting for this deskew. When I hit enter, although I've entered 175 nanoseconds up there, enter, you see it's only gone down to 125 nanoseconds, and as you can see they're not aligned. So in order to get them to align, I've still got 49 nanoseconds in between them. So to get rid of that, I'll actually have to go to channel 1 and move this the other way. So 49.5, and because I need to go the other way, I'll need to minus it, and now you can see still got a little bit more to go because I'm hundreds of picoseconds as opposed to tens of picoseconds. Even with the rise time, you can see the rise time is really not brilliant. It's going to be difficult to get this probe to give me accurate results with the kind of tests that we're doing. So what I'm liable to do when I'm doing the actual tests themselves is to replace the current probe with a series resistor and just measure the voltage across that, and I know that will be in phase and will have the same rise time, and I won't be stuck with the limitations of this probe.